All right, good afternoon and welcome to Mass Atoka online class. In today's video, we'll be talking about electric field. All right, but please, if today is your first day of watching our video, please click the subscribe button and like and comment. All right, okay, right. Electric field is a region where an electric force is experienced by a charged body. Very simple. Electric field is the region where electric force is experienced by a charged particle. It could be force of attraction or force of repulsion. Okay, that field where that force, either force of attraction or force of repulsion, okay, is being experienced is called an electric field. So, right, electric field is a region where an electric force is experienced by a charged body. All right. Now, full stop. Right. Electric field is a vector field, and it is similar to what? Gravitational field. You know that in gravitational field is only for the masses are for attraction, but in electric charges has two types. It could be attraction or repulsion. That is the only difference between gravitation and electric field. All right, so now let's talk about Coulomb's law. Coulomb's law. Coulomb's law. All right, right. Coulomb's law stated that the force of attraction or repulsion, okay, the force of attraction or repulsion between two charges, okay, is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. It's very simple. If you know gravitational law, you will know Coulomb's law. If you have not watched a video on gravitational law, please do that. Gravitational field, please do that. Okay, in gravitational field, it states that what? That the force of attraction is only attraction. So the force of attraction between two masses, right, is directly proportional to the product of the masses and inversely proportional to the square of their distance apart. But in Coulomb's law is what? Anywhere you see mass now, change it to charge. Okay, but you know that charge has two types of forces. It could be force of attraction or force of repulsion. All right, so we state that what? That the force of attraction or force of repulsion is directly proportional to the product of the charges. Let me say that the charges are Q1 and Q2, and then inversely proportional to the square of their distance apart. So let's assume that R is the distance apart. That is the distance separating them. All right. Okay. So if you remove proportionality sign, you bring in proportionality constant. That's why we have that F is equal to what? K Q1 Q2 all over R squared. All right. Then you need to know the value of K. K is equal to 1 over 4 pi E naught. All right. And this value is a constant. And what is that constant? The constant is 9.0 times 10 raised to power 9. I used to know it by 9 and 9. All right. But you need to know that this E is equally another constant. This is a constant called permittivity of free space or vacuum. All right. E naught is called permittivity of free space or vacuum. Okay. I'm coming to that. So let us replace K with this. Anywhere you see K in this formula, put this. This is one of the most important formula. Okay. The second one is that what? F is equal to, instead of writing K, I'll write 1 over this. So 1 times anything here is the same thing. Q1, Q2, all over this 1 time. This will give you 4 pi E naught R squared. All right. So you need to know that that your E naught is a constant, and that constant is called permittivity of free space. And the value of the constant, I think 8.85 times 10 raised to power minus 12, if I can remember. Let me cross check. Yes, 8. God bless you. 8.85 times 10 raised to power minus 12. Please, you need to know all these values. All right, you need to know all these values. They are very, very important. So you need to know that this E naught is called permittivity of free space or vacuum. All right, or vacuum. Okay, so that is that. This is an important formula to use. Very, very important formula to use. And you should know that okay, sometimes they can give you that Q1 is equal to Q2. So if Q1 is equal to Q2, okay, and let me say that both of them is just equal to 1Q, then we now have that F is equal to what? Q squared all over what? 4 pi E naught R squared. All right. So to know the SI unit of this K staying alone, this one multiply this. So I'm supposed to have that the SI unit of this is supposed to be Newton meter squared, then CC is Coulomb, then it will come down. So I have per Coulomb square. All right, that is if you make a subject of formula, you have that FR squared all over Q1 Q2. So F is Newton, distance is meter, and it is squared, half squared. Then this is Coulomb, which is Coulomb squared. But since it is down, we have it per Coulomb squared. So that is how we have that formula there. All right. So let's continue. And don't forget that in an electric field, we have that charges can repel or attract. Okay. And don't forget that like charges repel while unlike charges attract. If it's a like charge, for example, I have positive and another positive. All right, this one will be going this way, while this one will be going this way. So this is repulsion. Or maybe you have negative and another negative. This one will be going this way, this one will be going this way. That is repulsion. But if I have maybe positive and negative, there is an attraction. They will be attracting each other. Okay, or maybe I have negative and positive. There must be attraction. They are attracting each other. All right, so these are little things you need to know. So this is the force F1 F2 F1 F2 it's not F1 F2, sorry, the force F, sorry, this is force F, not F. This is force F, but this one is charges Q1 Q2 Q1 Q2 Q1 Q2. This is F here, attracting. The force are attracting Q1 Q2. Right, so that is that. So don't forget that this one like charges is what? A repulsion, while unlike charges is attraction. So let us solve some questions to illustrate what we have done so far. The first question we're going to solve said a body, okay, two bodies, each carries a charge of 2.00 times 10 raised to power minus 10 Coulomb, okay, are 5 cm apart. They say calculate the magnitude. Magnitude means size. Calculate the magnitude of the force between them. Right? Calculate the magnitude of the force between the charges. Okay, between the charges. All right. Solution. Now, very importantly, what did they give us? The first thing you look at is what they gave you. They say that two bodies carries the same charge. So we will now have that Q1 is equal to Q2 and is equal to what? 2.00 times 10 raised to power what? Minus 10. All right. They've given us the charge. And the distance apart, R, is equal to 5 cm. If you convert it to meter, you have that what? 5 divided by 100, which is what? 0.05 meter. Why am I dividing? Because whenever you are moving from the small one to the big one, you divide. But if you are moving from the big one to the small one, you multiply. Okay? So we have that. So the next thing you do is what? You write your formula. Don't forget that F is equal to what? Q1, Q2, all over what? In fact, K, Q1, Q2, all over R squared. All right? But I know the value of K. My K is equal to what? 9.0 times 10 raised to power what? 9. So let me put it here. I'll have the what? 9.0 times 10 raised to power 9 times my Q1 is equal to Q2. So I have 2.00 times 10 raised to power 10. Is that minus 10? Is either I make them squared or I times it again. 2.00 times 10 raised to power minus 10. Now everybody divided by 0.05 all squared. All right. If you punch it in calculator the way it is, you'll be getting 1.44 times 10 raised to power minus 7 Newton. All right. That is very, very simple question to answer. So the next one, question number 2. Question number 2 says that an electron Okay, they said an electron is at a distance of 5.0 times 10 raised to the power minus 11 meter away from the center of a proton. All right, we now have that what? Calculate the electrostatic force on it. Okay, calculate the electrostatic force on it. Solution. Now, the reason that they did not give you the charge of an electron or the charge of the proton is because the charge of proton is equal to the charge of electron in an atom. Okay, it's just that they are just of opposite signs, and the charge is 1.6 times 10 raised to power minus 19. Please, very very important. So you write charge of proton. Charge of proton is positive because proton is always positive. Don't forget, in an atom, while electron is negative. So you have 1.6 times 10 raised to power what? Minus 19 coulomb. Right? That is the charge of proton. So the next thing you get is the charge of electron. And the charge of electron is same thing. Charge of electron. Electron is what? Minus 1.6 times 10 raised to power minus 19 coulomb. Please, in the calculation, we are not going to use this minus. Please, we are just using the number. This minus shows that it is an electron. It's not that we are using the minus, but the minus shows that it is an electron. That is, for example, now, acceleration and retardation. Acceleration is what? Positive. Retardation is negative. So, but in calculation, we don't normally use that negative. We use the number. But the negative there shows that you are talking about retardation. Okay? Or if you get a negative answer, shows that what? You are talking about retardation. So, but we are not making use of the negative. So, we have gotten the two charges, and then their distance apart r. So, this is my Q1 and Q2. All right? Let me see. This one is Q1 and this one is Q2. All right? So, my r is now what? 5.0 times 10 raised to power what? Minus 11 meters. So, I will tell them that the force, I hope you know that this force is what? Force of attraction. Why is it attraction? Because the signs are what? They are of opposite charges. The charges are not the same. So it is a force of attraction. So the force of attraction between them will not be what? K Q1 Q2 all over what? R squared. Very simple formula. So what is my K? Don't forget that my K is always 9.0 times 10 raised to power the same 9. Okay? Then times 1.6 times 10 raised to power minus 19 times another 1.6 times 10 raised to power minus 19. You see, I did not use the minus. The minus is simply showing that it is an electron. So all over my R is 5.0 times 10 raised to power what? Minus 11 all squared. All right. If you want to press this in calculator, see the way you press it so that you will not make mistake. Just press this times this. Okay, don't press this in direct. Just press 9 times this times this times this times this times this. All right. Then you now press divided by this one first. If you want to press everything direct, then divided by this one. Repeat it again. Divided by this one again and divided by this one again. So you get your normal answer. Okay. So my answer, if I do that, I'm going to have that the force is 9.2 times 10 raised to power minus 8. I'm not with calculator here, so I'm just using what is already solved in the book. All right. So that is that for that. So the next question number 3. Question number 3 said two identical charges situated at 20 cm apart in vacuum, okay, repel each other with a force of 1.0 Newton. Okay, they say calculate the value of each charge. Calculate the value of each charge. All right. Now, to calculate the value of each charge is very, very simple. Solution, what do? We have that Q1 is equal to Q2. And let me say that they are just equal to Q. All right. And then I have my R is equal to 20 cm, which is what? 20 divided by 100, which is 0.2 meters. All right. Now, the next thing we have is force. Now, the force is what? 1.0 Newton. But I know that my force is equal to what? KQ1, Q2 all over what? R squared. Which can be, since they are the same, I'll have that what? My F is equal to what? KQ squared all over what? R squared. Are you getting it? But don't forget that your K is always 9.0 times 10 raised to the power 9. 9 and 9. All right. So let me put everybody here now to get my R. I'm looking for Q squared and my Q. So I have that 1 is equal to what? 9.0 times 10 raised to the power 9 times Q squared all over 0.2 all squared. So if I make my Q squared subject of formula, this one will go this way, this one will come down. So I have that my Q squared is equal to 1 times 0.2 all squared. Now divided by 9.0 times 10 raised to the power 9. So my Q will now be the square root of that answer. So the square root of that answer, that is the square root of 4.4 times 10 raised to the power what? Minus 12. So if you get the square root, you now have that your Q is what? Your Q is 2.1 times 10 raised to the power what? Minus 6 Coulomb. Okay? Which is what? Q is equal to 10 raised to the power minus 6 means mu is 10 raised to the power minus 6. So I will have 2.1 mu Coulomb. Okay? Don't forget that this thing means 10 raised to the power minus 6. Okay? That is that. And it's a very simple question to solve. So we move. The next question there said, question number 4 said, two protons each of charge Q and mass m, are separated by a distance r. The first question said, write down an equation to express the ratio of the electric field. Okay? Electric field of repulsion and the gravitational field of attraction. Gravitational force of attraction, electric force, not electric field. Electric force of repulsion and gravitational force of attraction between them. Then I now said, define other symbols used apart from the given parameter. Okay, this is a very simple question. So what do we do here? The first thing we do is we need to write the force of attraction between the charges. Okay, let me call it Fe. Fe should represent electric force. We are talking about electric force, and if it's electric force, we have that what? That the charge Q squared, KQ squared all over what? R squared. Okay, then for this thing, what is it? Gravitational force. Let me call it Fg. Fg is equal to what? Kg squared all over r squared. All right. Then we want to know the ratio between them. The ratio means dividing, and they mention electric first before gravitation. So if I say Fe divided by Fg is going to be what? K K sorry, don't forget that what this one, what we use here is not K but capital letter G. That's what we use here. Gravitational constant, that's what we use here. Why this one is what? Electric field constant. Okay, so we have that. Okay, before that we know the value of our K. So I have that Fe is equal to what? Q squared all over 4 pi E naught. Okay, R squared. Then they said that the ratio, that is Fe divided by Fg, which is what? Let's go. G squared over 4 pi E naught R squared divided by GQ squared all over R squared. So if you change division to multiplication, you have G squared all over 4 pi E naught R squared times R squared all over GQ squared. Okay, sorry, this one is not Q but the mass. Sorry, this is the mass, M squared. Sorry, this is the mass. Okay, because in gravitation is the force of attraction between the masses and not between the charges. Okay, so that's the mistake there. So if we have this, we now have that what? That Fe over Fg is equal to what? We cancel out this, we cancel out this. So what do we have? And then R, we cancel out R. So we are having that we're having only 1 over 4. What do we have? Okay, so sorry. So this is not, this is R squared. There is no cancellation here, please. Q squared. So R squared all over G M squared. So it's only R squared that is cancelling R squared. So I am left with Q squared all over 4 pi E naught G M squared. All right, 4 pi E naught G M squared. So that is the ratio between them. So we don't need to list your parameters like they said. We should read the parameters. We'll tell them that this is what? Your pi. This is your pi and is a constant 22/7. So this is your pi. Okay. Then E naught. Don't forget E naught. E naught is permittivity of free space or vacuum. E naught is permittivity of free space or vacuum. And don't forget the constant. It is 8.85 times 10 raised to power minus 12. Okay, please don't forget all these values. They are very, very important. So you write that this is permittivity of free space. Permittivity of free space or vacuum. Okay, so the next one you look at, the next thing there is G. I told you that G is what? Gravitational constant. So which other one? Fe. Tell them that F is what? For electric force. Then Fg is what? Gravitational force. And then you are done listing the elements there. Okay, you are done listing the elements there. All right, so that is that for that. So the next thing, let us solve one question from the exercises of the textbook. Let's solve one question from the exercise of the textbook, right? All right, that is question number 1. Okay, they said a metal is tested to have a charge of 697.6 Coulomb. Okay, then I say how many electrons are added to it to enable it acquire acquire the charge. All right. Then the now say if question continue, that is, let me call this 1 and this 2. They said if two of similarly charged metal are brought 1.5 meter apart, okay, in a medium of dielectric constant, 2, comma, then I say calculate the force between them. Okay, then the now say is the force attraction or repulsion? Attraction, okay, attractive or repulsive, okay, or repulsive. Okay, this is a very simple question. So what did they say we should do? The first thing that we are given the charge of that particle. This is charge of the metal. The charge of the metal is 697.6 Coulomb. Okay, then I say how many electrons? So let's get the charge of electron. Charge of electron is what? Minus 1 point what? Don't forget, minus 1.6 times 10 raised to power minus 12. All right, Coulomb. And don't forget that this minus is not being used in calculation. The minus is just showing that it is what? It is an electron. All right. So the number of electron added is simply this divided by this. As simple as that. Okay. The number of electron. Okay. Number of electron added is equal to number charge of particle all over charge of electron. Yes, charge of that object or particle all over charge of electron. Okay, so what do we have? So charge of particle is 697.6. Now divided by what? 1.6 times 10 raised to power what? Minus 12. So if you do that, you're going to have 4.36 times 10 raised to power 21. Okay, no SI in because Coulomb, we cancel Coulomb. So that is the number of electron that is required to enable that is required for the charge. Okay, so that is that. So the next one, question number 2. The question number 2 there says that this is continuation of this, please. They said if two similar charges of this, okay, are of that metal are brought by a distance of this. So I have that Q1 is equal to Q2 and is equal to just one single Q, and they gave me that it is what? 697.6 Coulomb. Okay, and their distance apart is equal to 1.5 meters. So then I say I should calculate the force. I know that my F is equal to what? Q1 KQ1 Q2 all over what? R squared. KQ1 Q2 all over R squared. But the only thing there is that they gave me what they give me? They gave me the dielectric constant. And what is dielectric constant? That is ER is your dielectric constant. And dielectric constant they gave me there is 2. So since they gave me dielectric constant, I am not going to use this K again. So what I will tell them that what? My F is equal to what? Q1 Q2 all over 4 pi, okay, 4 pi ER E naught, then my R squared. It's supposed to be just 4 pi E, okay, 4 pi E. But whenever you have your ER, please, you must attach it to it. I am going to show you that as we progress, okay. So if you now put this, you are going to have your 697.6 times another 697.6 divided by 4 times 22, 4 times 3.142 times 2, then times, don't forget your E naught. My E naught is what? 8.85 times 10 raised to power what? Take minus 12, right? Yes, minus 12. Minus 12, then times what? Times, what am I saying? Then times 1.5 all squared. Yes, arrow squared, that is 1.5 all squared. So if you now press everything in calculator, you're going to get 9.73 times 10 raised to power 14 Newton. Okay, and they say that what? That if two similar charges are brought by this, is it repulsion or attraction? Since they are of similar charges, which means the charge are the same. The charge are the same, and if the charge are the same, what do you have? Repulsion. So you tell them that it is what? Repulsive and not attractive. All right. So you tell them that it is repulsive. Why is it repulsive? Because the charges are similar. That is why it is repulsive. But if they have different charges, then it will be attractive. So the next question there, question number 2 said, question number 2II said two equal charges are separated 75 cm apart, okay, in free space, that is vacuum, in free air. All right, we are going to use permittivity of free space, okay, in free air. And then they said calculate the quantity of either charge if the force between them is 0.17 Newton. Okay, then I say continue. What will be the quantity? What will be the quantity if the charges are situated in an insulator, in an insulating medium of dielectric constant of 10. Okay, so let us solve that. This is very, very simple. So let us get our parameters, then we solve. Okay, so getting our parameters, we have that two equal charges, they are equal. So I will tell them that Q1 is equal to Q2, which is just equal to Q. Okay, and they gave me that their distance R is what? 75 cm, which is what? 75 divided by 100, which is 0.75 meter. Okay, 0.75 meter. Now the next thing they gave us is their force. They say that the force is 0.17 Newton. So, but I know that my F is equal to what? KQ squared, if they are the same, all over what? R squared. All right. So if I put everybody, I'll have that 0.17 is equal to my K. Don't forget my K is always 9.0 times 10 raised to power 9. Okay, don't forget that 9.0 times 10 raised to power 9. So if I have 9.0 times, but if you don't want to use this, you know what to use. If you don't want to use it, you can use Q squared all over 4 pi E naught. Okay, E naught R squared. And you know what your E naught is now. E naught is always what? 8.85 times 10 raised to power minus 12. Okay, so don't forget your E naught to be that. But if you don't want to use that, you can use this. So I have that my K 9 times 10 raised to power 9, then times my R squared that I'm looking for, all over 0.75 all squared. So if I make this subject of formula, this one will go up, while this one will come down. So I have that R squared is equal to, if you cross multiply, that's what I'm doing. So 0.17 times 0.75 all squared, then all over 9.0 times 10 raised to power 9. So you now have that R will now be the square root of, because when square cross, it becomes square root. So you have the square root of 10. Where am I? So 10.636, okay, times what? 10 raised to power minus 12. Minus 12. So if you get that, you get your Q. Please, I don't have calculator. Please punch it in calculator by yourself. So I have 3.26 times 10 raised to power what? Minus 6 Coulomb. So that is that. It's very simple. Okay. So they now said, what will now be the charge? What will now be the quantity of the charge if they are situated in a in an isolating medium of dielectric constant? They've given your ER. Now, what did I tell you? Whenever you are giving ER, please permit me to clean here. If you are giving ER, they gave me ER, E naught. So they gave me ER to be what? 10. And I told you, if you are giving ER, you are supposed to use that what? F is equal to what? Q squared all over 4 pi. That's ER first, then E naught. Okay? Then your R squared. Very simple. That is if ER is given. But if ER is not given, then this one will not be here. So if you now put it, you are going to have, what do we have? Put everybody. Okay, sorry. I have my 0.17 is equal to what? Q squared all over 4 times 3.142 times 10. Then what? Times 8.85 times 10 raised to power what? Minus 12. Okay, then times 0.75 all squared. So if you do cross multiply, everybody here will go here. So what do I have? I will now have that my Q squared is equal to what? 0.17 times 4 times 3.142 times 10 times 8.85 times 10 raised to power minus 12, then times 0.75 all squared. So if you press everything, you have that R squared will now be R squared will give you 106.36 times 10 raised to power what? Minus 12. So Q will now be the square root of 106.36, then times 10 raised to power minus 12. So my Q will now be what? If you do the square root of that, you have 1.03 times 10 raised to power what? Minus 5 Coulomb. Okay, that is that. Very, very simple. Very, very simple. So I'm going to stop here. In our next video, we continue from where we stop. Please, if this is my first video you are watching, don't forget to subscribe. Okay, bye bye.